Hi, I'm Sam Washko. I'm a software engineer with Protect AI, and today we're demoing ModelScan, our open source tool for scanning models to protect against model serialization attacks. Before we demo, here's my colleague Marin to talk about the importance of scanning models.
Thank you so much, Sam. I'm Mehreen Kiani. I work as a machine learning researcher at Protect AI. ModelScan can read a model file and verify for us whether the contents of the model file are safe to be loaded or not. Often the way models are saved so that upon loading they can be used directly for inference implies that loading them can execute malicious code. What that means is that attackers can also use this feature, inject malicious code in a model file, and deliver attack on ML systems via machine learning models by simply scanning the model with a command away. So you say model scan, give the path, and it's going to tell you whether the content of the model falls into security levels of critical, high, medium, or low. Because ModelScan can read a model file, it never executes malicious code if it is present in your model file. This gives users like us a very nice heads up whether a model file is safe to be loaded or not.
Thanks, Marin, for that high-level overview. So to actually use ModelScan, it's pretty simple. You can get the package through a pip install, or you can clone our Git repo and build it yourself to see all the open source code. So a basic call is ModelScan, passing in the path through the flag path, or -p for short, and having the path to your machine learning model. And you can see the output has a critical vulnerability because it found an unsafe operator. So it'll show you any issues that were found based on severity levels, and it'll also surface any issues that ModelScan found during the scan. So it can be scanned on a number of different model formats. This one's a Keras, H5, and we can see that it detected a lambda layer, 2 lambda layers in the Keras file. It can also be run on a directory of different files, so it'll scan each file in that directory. So we can see that it found a couple of different vulnerabilities because it scanned a couple of different files here. So with our recent release, we've made the tool a lot more robust and configurable. So each scanner is modularized to run independently and be able to be configured through a settings file. So to create the settings file, run ModelScan, create settings file, -f flag is to force it in that location, -l is the location to put it. If you don't pass in a location, it puts it in the current directory. So if we run that, we're going to see that a settings.toml is created with all of these default settings, have all of our default scanners, Pickle unsafe ops scan, NumPy unsafe ops scan, PyTorch unsafe ops scan, all run for a number of potentially suspicious Python operators. Save model TensorFlow ops scan scans for the TensorFlow operators of read file and write file. The Lambda-related Keras scanners all scan for whether a Lambda layer is present, because Lambda layers could have arbitrary code. And in the settings file, you can enable or disable different scanners, you can change severity levels, and you can also add your own custom scanner if you want. So then once you have a settings file, you can pass it back into the ModelScan using the flag for settings file. So now that we're running it with the settings file, it says that it detected the settings file and is using that. So by default, the report is going to be in this console human readable format, but if you want it to come out as a JSON, we also have a flag for reporting format, or -r for short. So if you put JSON, it'll come out with all the information that was in that human readable format in a JSON. You also have the option of an output file for the JSON, and that will write the JSON to the output format that we specified. You can also specify the reporting format as custom, which will read from the settings.toml for which format it should use. So if we run that, settings.toml right now is set to the console report, so we get that, but you can also write your own custom reporting format and specify that in your settings file. So far we've talked about using ModelScan through the CLI tool, but you can also use it as a Python SDK. So importing ModelScan, creating a ModelScan object, and then passing in the path will give you a Python dictionary with the results in it. So we can see that it has the same critical vulnerability that the CLI tool found. You can also modify the settings through the Python SDK. So I'm importing the default settings and setting pickle unsafe ops scan to be disabled. So now when I run it, it's not finding anything because I disabled the scanner that was finding the issue. We can also modify things like the severity level. So let's say I don't care about Lambda that much, I just want to put it as a low severity. I can run it on this file and it only found a low severity vulnerability. You can also add a custom scanner through this. So for this one, I wrote my own custom scanner. You have to say that it's enabled, and we put it in our settings file. And when we run it, now we see that it came up with custom results. Hope you found this insight into ModelScan helpful. For more information about ModelScan or to check out our other open source projects designed to enhance the security of your AI/ML workflows, please check out the link on the screen.